So in this video, we're going to do some work with the unit circle, and we're going to, by the time this is all said and done, have computed the secant of pi by 6 without using a calculator, cosine of 11 pi by 6 without the use of a calculator, and also the cotangent of 4 pi by 3 without even touching the calculator. Now, to get to the point where we can do this, we've got to kind of have a little bit of background information in place. And so in trig, I'm sure something that you've spoken about are special right triangles, mainly a 30, 60, 90 right triangle and a 45, 45, 90 right triangle. Now for any right triangle that has angle measures of 30, 60, and 90 degrees, your sides are always going to follow this sequence of proportions. The smallest leg is always going to be 1 unit in length. The hypotenuse is always going to be double what the smallest leg was. And then the leg that's between the lengths of the other two sides is going to be given by square root of 3. Now, if we wanted to figure out what the sides on one of these 30, 60, 90 triangles were, if this right here was, say, 4 units in length, then we'd multiply all 3 of these values by 4, and we'd have the sides of that triangle. So the 30, 60, 90 triangles are always going to have sides that are proportional to each other through this relationship, and a 45, 45, 90 triangle is going to actually be an isosceles triangle, and so the proportion that you've probably remembered about lengths of sides of 45, 45, 90 triangles would be your legs are going to be the same length, and we're going with 1 and 1. And the hypotenuse, if you follow the Pythagorean theorem and figure out what the length of the hypotenuse would be, is always going to be square root of 2. And similarly, if this was supposed to be of length 5, we just multiply all 3 of these values by 5, and we'd have the lengths of a slightly bigger 45, 45, 90 triangle. But we'll go ahead and talk about one more screen's worth of background information, and that would be something that you have to know about the unit circle. The unit circle is a circle. It's centered at the origin, so it's graphed within the coordinate plane, and it has a radius of 1. Now, if you plot a point on your unit circle and you define theta to be the angle that you open with from the positive portion of the x-axis to that point that you've plotted on the circle, you can actually draw this little triangle in right here. And across the bottom, that value is actually going to correspond to the x-coordinate of this point. The distance up right here is obviously going to be the y-coordinate of this point. And then since this is the unit circle, the radius is what we have on the hypotenuse of this triangle you see I've drawn here, and that's going to be 1 unit in length. Now, if you want to develop a relationship between x and theta, what you can actually use is you can use the cosine ratio. Right? Cosine is adjacent over hypotenuse, so cosine of this angle is going to be x over 1. What that means is anywhere we sit on the unit circle, the x-coordinate of the point we're looking at is always going to correspond to cosine of the angle that we're opening up with to get to that point. Similarly, you can develop a relationship between theta and y with the sine ratio. Sine of theta is going to be opposite over hypotenuse. Y over 1 is just y. So the y-coordinate of any point on the unit circle is always going to correspond to sine of the angle that you're sitting at. If we use this screen's worth of information in conjunction with what we said back here about the 45, 45, 90 and 30, 60, 90 triangles, we're going to be able to do all these computations that we ran through at the beginning of this video. So we want to start with the secant of pi by 6. Now, we just got done talking about the unit circle a little bit, and we didn't say anything about trigonometric ratios other than sine or cosine. So anytime you're trying to use the unit circle and you don't have sine or cosine as the trigonometric ratio that you start with within your problem, you're going to want to change it to an equivalent statement that is in terms of sine and cosine, sine or cosine. In this case, secant is the reciprocal of the cosine function, and so this calculation is going to amount to the same thing as 1 divided by cosine of pi by 6. So once you have the angle that you are concerned with, you want to go ahead and plot that on your unit circle. So pi is equivalent to 180 degrees. And so what we have going on within the cosine function within this denominator is we have pi being divided by 6. Well, if we divide pi by 6, we'd have to divide 180 by 6, and that would give us 30 degrees. So pi by 6 radians corresponds to 30 degrees, and this, oh, I'm having a little trouble here, let's try that again. This angle right here would correspond to pi by 6 radians. It's equivalent to 30 degrees. Now, why were those 30, 60, 90 ratios discussed a little while back? Well, if I come down from that point to the x-axis and then come over across the x-axis, what I have right here is I have a 30, 60, 90 triangle, right? This is equivalent to 30 degrees. We just said that by looking at this statement up here. This is obviously 90 degrees. That makes this 60 degrees, or pi by 3 radians. Now, if we want to use the 30, 60, 90 ratios to help us figure out the value of this, we're going to have to remember what the 30, 60, 90 ratios were, and that was 1, 2, square root of 3. And so this was the smallest side on the triangle, this was the hypotenuse, and this was the other leg. And so what we're going to have to do is we're going to have to make sure we adjust these ratios so that the biggest side is the same as the radius of our unit circle, or the hypotenuse of this triangle that we just drew over in the first quadrant here. And so we can turn that 2 into a 1 by dividing by 2, but we're going to have to divide all the other sides by 2 as well. And so the lengths of the sides of this 30, 60, 90 triangle that has a hypotenuse of 1 should end up being 1/2, 1, which we already have labeled, and then square root of 3 over 2. Well, it's pretty obvious that the side that is along the x-axis is the largest of the remaining sides. So that's going to be the one given by square root of 3 over 2, and then this is going to be a value of 1/2. Now, how does what we just threw onto this triangle right here on our unit circle diagram help us figure out the value of this trigonometric ratio? Well, what we can go ahead and do is we can say that on the unit circle, cosine is always specified by the x-coordinate. We looked at that on the previous screen. So this calculation is going to be 1 over cosine of pi by 6 corresponds to the x-coordinate of the point that we sit at within the unit circle there. And that's going to be square root of 3 over 2. Now, rather than dividing by square root of 3 over 2, we'd likely rather see that written as multiplication by the reciprocal. So I'm going to do 1 times 2 over root 3, and that's going to be the value of cosine of pi by 6. If you wanted to simplify this, get rid of the root in the bottom, you could multiply by 1 in the form of root 3 over root 3. If you don't mind a root appearing in the denominator right there, there is the value of secant of pi by 6. If we check out this next problem, we're looking at cosine of 11 pi by 6. So we don't have to really turn anything into a statement that involves sine or cosine. We're starting with that here. We want to do the cosine of 11 pi by 6. I do want to recall the same thing that we looked at on the last screen, and that's that 180 degrees is equivalent to pi radians. We see pi being divided by 6, right? And when we divided pi by 6, earlier in the last problem, we got 30 degrees. So just pi by 6 corresponds to 30 degrees. Well, we have to do that 11 times. And so we're going to have to go 30 degrees around the unit circle 11 times. You can multiply 30 and 11 together to figure out where you're going to sit. And I think what you're going to end up with is you're going to end up with 330 degrees. Now, if you think about it, 360 degrees would put you right here, back, the whole way around the circle. We have to be 30 degrees shy of that. So plotting this point on the unit circle is going to leave us with a point down here in the fourth quadrant. I'm going to do the same thing we did before. I'm going to go ahead and I'm going to draw my radius of my unit circle in. I'm going to come back to the x-axis here, and I'm going to complete a little triangle. So this angle right here is 30 degrees, or pi by 6 radians. And what we want is we want to know what cosine of 11 pi by 6 is. Now, this triangle right here is another 30, 60, 90 triangle. We know that it's within the unit circle, so the hypotenuse of that right triangle is really the radius of the unit circle. And now we want to do what we did before. We want to break out our 30, 60, 90 ratios, and so that would be 1, 2, square root of 3. We want to turn the hypotenuse into a 1, so we're going to have to divide by 2, and we're going to have to do that for all 3 pieces. So the longest leg on this triangle is once again going to be square root of 3 over 2, and then this leg is going to be 1/2. And what we wanted is we wanted the cosine of this angle that we sit at right there. Well, this length across the x-axis is really the x-coordinate of the point that we sit at right here, and that's also going to be equivalent to cosine of the angle we've plotted. And so this is actually a little easier than I thought going into it. We're going to end up with the square root of 3/2. We need the x-coordinate of this point, and we got that with a little bit of help from our 30, 60, 90 ratios. Now let's say, I know this wasn't the problem we started with, but watch how easy it is to adjust and do sine of 11 pi by 6. We've already got the angle plotted, we've already got our triangle drawn, we've already got the sides on that triangle labeled. If we're looking for sine of that angle, what we've got to do is we've got to recognize that sine of an angle of anywhere we sit on the unit circle is going to correspond to the y-coordinate of the point we're at. And we know that this value on the triangle is 1/2 units in length. Since we're going for the y value of this point right now, all we'd have to recognize is that y value is negative, and this is going to end up being negative 1/2. And then the one that we'll wrap up with here is going to be for the cotangent of 4 pi by 3. We do want to re-express this in terms of sine and cosine since we're not starting in that situation. And so that's pretty simple to do here. Cotangent is the reciprocal of tangent. Tangent is sine over cosine. So the reciprocal of that is going to have cosine in the top and sine in the bottom. So we need to do the cosine of 4 pi by 3 and divide by the sine of 4 pi by 3. We're going to go ahead next and do what we've done in the previous two problems, and that's try to figure out where to plot this point on the unit circle. So we'll start with the same statement. 180 degrees is equivalent to pi radians. Well, we're dividing pi by 3 for the angle that we're looking at right now. If you divide pi by 3, what you end up with is 60 degrees. Because 180 divided by 3 is obviously 60. We need to do that 4 times. So we've got to do 4 times 60 degrees, and that's going to give us 240 degrees. So obviously 180 degrees would be right here. We need to go 60 degrees beyond that. So we need to go 60 degrees beyond 180, and that'll put us down to this point right here. Same thing we've done in the previous two problems, I'm going to do again now, and that is to try and draw a little right triangle in right here. So there's the right angle on this triangle. We said a minute ago that we'd be going 60 degrees or pi by 3 radians past 180. And so we're looking at, once again, I happen to pick 3 that were all 30, 60, 90 triangles here, but we're looking at another 30, 60, 90 triangle. And so our ratio once more is going to be 1, 2, square root of 3. We know that the hypotenuse of this triangle is 1 because it's the radius of the unit circle. So again, we're going to turn that hypotenuse into a 1 by dividing everything by 2, and we've got to divide all side lengths by 2. So the biggest side length here is going to be square root of 3/2. Should be pretty obvious that that's the vertical side on this triangle, or the biggest side length that's left. The biggest one overall is obviously the hypotenuse, and then the shorter of the 2 legs is going to measure 1/2 unit. Now what we want here is we want the cosine of this angle. Well, that's going to correspond to the x-coordinate of this point. Well, the x-coordinate of this point is not 1/2 because we're coming backward to the left from the origin, but it is negative 1/2. And then if we wanted to find the sine of 4 pi by 3, we just need to specify the y-coordinate of this point, and we know that this dimension on the triangle is square root of 3/2. But since that's below the x-axis, the y value is obviously negative, and then you just want to simplify this, clean this up a little bit. Negative divided by negative is obviously a positive. You probably want to multiply by the reciprocal. These are going to cancel, and you're left with 1 over the square root of 3. And again, if you wanted to simplify that, if you don't want the root to be in this denominator, you can multiply by 1 in the form of root 3 over root 3. But if all you care about is the value of this computation, cotangent of 4 pi by 3, we've just determined that.